to get started here. Awesome. Okay. Great. Hello, everybody. My name is Dustin DeVoe. I'm a senior technical animator at Epic, and welcome to creating Performant Metahumans in Unreal. I want to start off by saying thank you to Jared Monson and the Metahuman team, who Jared couldn't make it this time, so I'm presenting on his behalf. So I want to thank them for allowing me to present their work on behalf of getting this out to you guys, because I think it's going to be super useful for folks that are using Metahuman moving forward. So on the agenda today, we're going to talk a little bit about Metahuman 5.6. There's been a significant amount of updates. We're going to go over some of the features and do an overview there. Then, we're going to get into the actual technical aspects and trying to optimize our metahumans by doing a technical breakdown of what a metahuman is and what constitutes inside of it. Then, we're going to go into some performance profiling tips, how to help find those issues, and then lastly, some of the optimization opportunities that you can take and what we've learned as Epic helping other folks like you who are using Metahuman abroad. So, the biggest change with Unreal 5.6 is that we brought Metahuman Creator inside of the engine. And we've taken all the good things that were in the web app and brought them into the application where you work. It's a really exciting milestone overall. And the workflow takes those good parts of the web app, brings them in, reimagines that workflow, makes it local authoring. You can save things locally and handle your asset management. We do still have cloud enhanced features, things like skinning, that will send information off to the cloud and then return back. But you can also take all that local workflow and apply it to your live animation evaluation directly within the engine. It makes it even easier to create a metahuman. On top of that, we've grown the fidelity from moving it from the web to the app inside the engine. We were able to grow the database and the overall fidelity of our metahumans, adding new textures and materials that are also more optimized, and much more representation for you to create better looking metahumans and also wider ranging metahumans moving forward. And every aspect's been updated. So on top of that, because the database has grown in fidelity, you have much more precision and control over aspects of your metahuman faces, and you can control, manipulate, and change your metahuman through things like uniform region scaling, as well as translation and scaling along specific axes in the face to get that perfect metahuman that you're looking for, all within Unreal. And we're also super excited to announce the parametric body system. Finally, you have control over all your body types inside of the editor. And this has been a big feature that the metahuman community has been asking for a long time. So what you're seeing here is the parametric body system, and it comes with a lot of blending presets, and it can be a little daunting. You can adjust things like height, muscularity, and a bunch of other aspects of your body. You can pin and unpin constraints, so you control specific aspects of your anatomy while adjusting while keeping aspects of the other anatomy left alone. And if the numbers of the parametric body system feel a bit too technical, don't worry. Just like the face, we brought in all the same blending techniques to be able to say, I've got a preset here and a preset here, and I can blend those together to find and play around to explore those different body styles to find the one that you're looking for. You can take any preset, drag it into the blend tool, and then you can blend the whole body or just specific parts too, similar to like I mentioned with the pinning, to create your metahumans. And you can still use the old previous body type styles. If you're a studio that is upgrading from 5.5 to 5.6, don't worry, none of your workflows are lost or anything like that. You don't have to start all over. You can go up into the toolbar, you can turn on the fixed body type option, and you get access to those old fixed body types, and you can take the body types that you've created, bring them into the body blender, and start to utilize the new parametric body system all at the same time. So On top of that, any compatible garment can be added to the parametric body system, so you can import your own models or you can buy them on Fab, and you can bring them into Metahuman Creator and then add them to your character, and then they will morph and resize with your body as well. And it's more than easy now to assemble a Metahuman with clothing than it ever has been. And we've also added, for those advanced users who've worked with the DNA files, it's been kind of tough in the past. You would have to go into Maya, it was very technical, and now we've significantly reduced how hard this is by introducing Maya, Metahuman for Maya, where you can modify and edit your meshes using the DNA as well, so that you can match things. Maybe you have a face or reference scan that you want to match better with your Metahuman. You can make those edits, get them in there, and then output that DNA file back to Unreal, and it's as easy as it's ever been in that regard. It's all grounded in morphology, and if you use the expression editor, you can make stylized edits or tweak poses to make them even stronger. It all is much more malleable to hit further differentiation in your metahumans if you want to go that deep. And on top of that, we've added a Houdini toolkit for Metahuman where you can make new grooms. And the result is we've got a groom tool where you can create groom assets inside of Houdini that are much more complex, and it's easier to do, more easy to do than it ever has been, and you've got more styling tools. There's a lot of information here. Hugo's gonna be doing a talk later today, I think at 5 p.m., where he's gonna go over these tools, but I highlight it because one of the optimization things that we need to care about is how we build our grooms and how we think about grooms. And the groom tools and the way that they're set up, the first elements that we built are dedicated to creating complex hairstyles like buns, braids, and cornrows, and you can do this stuff within minutes, and it creates really great looking results. And one thing you notice when you open up the new Metahuman Creator is you're gonna see the new preset gallery. And this is what it looks like. The preset gallery was a signature feature of the original Metahuman Creator that was for the web, and we've added many, many more presets for you to build off of. And thanks to all the blending tools, it's easier than ever to experiment and customize a new face from these presets. And even better, you can manage your Metahuman assets directly in this preset editor, bring your new assets that you might have created into those presets and start blending them with those presets as well. On top of all of these things, all of these new features, we've changed the licensing for Metahuman. So Metahuman now is included with the Unreal Standard Engine license, and we've also added Metahuman for Maya and Metahuman for Houdini into Fab under the Fabula. And the goal here is that you can use Metahumans anywhere that you want. You can create a Metahuman, bring it out into Maya, you can bring it out in Houdini, you can use it in-game, you can use it in your film, it's fine. The idea is we want to bring Metahumans to more folks than ever, and these tools allow you folks to do that. And lastly, we have a dedicated webpage for Metahuman called metahuman.com. This is a resource site dedicated to Metahuman documentation, community, feature sets, and learning. So check this out if you haven't seen it. We just launched it with the Unreal Fest Orlando, and you can learn all the new features there as well. Okay, so now we get into the optimization set of Metahuman. You decided that you want to use a Metahuman. How do we actually start approaching the problem? So the first thing that you want to do, we've built in some stuff to Metahuman 5.6 that optimizes things automatically from things that we've learned. And if possible, we recommend updating to Maya 5.6. One of the key places that was an optimization problem was the pose drivers that were inside of the anim graph. The pose drivers in the anim graph were a significant cost, and we baked them into rig logic in 5.6. Rig logic is the node that runs a lot of the animation features for facial animation and body animation. Previously, the pose drivers on a normal, like PS5, would cost about 1.4 milliseconds to animate per character. But by moving them into rig logic, we've reduced that cost down to 0.4 milliseconds. And this was an even bigger, significant change for Switch users. It would take 8.5 milliseconds to run pose drivers for one character, which is basically untenable, and it's reduced that cost down to that 0.4 milliseconds as well. And that improvement in quality makes Metahumans viable on a range of platforms from high-end PCs all the way down to Switch. On top of that, another performance thing that we've done in 5.6 is we've removed the NMVP, the face NMVP specifically, from the chain. And now that opens up a few options for us, because on top of removing and just not evaluating an AND blueprint, it also allows you to do things where you can layer in facial animation through the post-process blueprint. I'll talk about that in just a second. And in general, by removing the face NMVP, it was just much more intuitive. We've also made changes to the face post-process NMVP, with the goal here being that we can simplify the overall NMVP workflow and leave the post-process NMVP open for you to layer in animation. We also have some alternative live link usage. So there's a checkbox in the live link where you can say, use live link or don't. And when you do this inside of Metahuman Creator, it swaps out the NMVP and allows you to connect things without all of that logic that used to be in there automatically default in the NMVP. So in 5.5 and before, you would have the ArcKit logic and the live link logic inside of the NMVP, but now that stuff is removed to remove that overhead. And those are now in their separate NMVPs, so if you want, you can also swap that if you'd like, if you need it. So overall, the animation pipeline is much more clean, it's much more linear. You've got your driving animation for your body, including potentially facial animation curves from your captures of your live link that play through the body. Then you have your body post-processing NMVP, where you handle twist bones and other correctives. And then you have your face post-processing NMVP that handles layering facial animation if you want. And overall, the other aspect to the face post-processing NMVP is we have the head movement IK. You can turn that off entirely too. And that makes overall things cheaper for you as you're getting things prepared for game. So, we know that there's improvements, but what is a metahuman when you export it in 5.5 and 5.6? Typically, metahuman comes with a couple of different pieces. There are separate meshes for the face, the body, and any clothing. And if you've worked in any performance or optimization land inside of Unreal, you know that the more components that you have on your anime blueprint or on your character blueprint add overhead and cost. The other thing is that your grooms are another components that you add as children to your character, and all of these equate to a high fidelity character, but with multiple components associated with them. So when you're approaching performance and optimization, you decide that you're going to use Metahuman, you've got 5.5 or 5.6, and you have these new features, you need to think about the context in which you want to use your Metahuman. There's a lot of different ways that you can use them. If you have, say you have a single player game with a hero and you want to use a metahuman for that, that's going to change the way that you think about which metahuman type you want to use. Maybe you have a squad, you're building a Fortnite-like game and you want to have a squad of people, they're all metahumans. You're going to change the way you approach your optimization. If you're trying to build crowds, you may want to have a lot of metahumans, and that's going to be very tough to solve, but it's totally possible now, and you have to do a bit of work to do that. But each layer of this puzzle is going to equate to a different type of metahuman and types of things that you want to think about. And scalability is more than just lots. So when you're thinking about scalability, think about your platforms, think about your scalability settings, your device settings, think about your target platforms and what you need to do to set that up. If you're building a cross-platform game, you're going to need to think about potentially different metahumans and different types of settings to handle your gameplay. And the best thing that you can do is think about your target platform, your primary one, and go from there. Also, a really simple thing is your camera distance. If your camera is not going to get close to your metahuman, you may not need to have some of the high-end features that metahumans provide. But ultimately, there's no magic button. there's going to be work once you create your metahuman to do to get it optimized for your game. So, Metahuman, both old and the 5.6 update, has the ability to create optimized metahumans. These are pre-processed metahumans from the fully cinematic version that we optimize in a couple different areas. LODs, animation performance with the metahuman component, groom reduction techniques, and material and texture optimizations. So in Metahuman Creator, you create and decide on what your metahuman looks like. Do not export the full cinematic metahuman. The goal here is to get a more optimized one. And full cinematic metahumans are meant for like film, for example, or very high-end pre-rendered cinematics. So there are settings where you can choose high, medium, and low, and even high can be very game intensive. And the output of this is you can see this with the average clip size. A full cinematic metahuman is about 800 megabytes on disk, which is huge. And just choosing the high-end version of the metahuman goes down to 60 megabytes, which is much more reasonable in terms of setup for your game. Okay, so we've decided that we're going to use metahuman. We've decided that we're going to use one of the optimized metahumans, and we put it in our game, and now we need to figure out where our performance optimization opportunities could be. And this is where we get into learning how we're going to profile for metahumans specifically. The first thing that you want to know about when you're dealing with metahuman profiling is that there's a couple key areas where metahumans themselves show up inside of profiles. The first one is skeletal mesh components. Like I mentioned before, all the metahumans come with multiple components, and depending on the size of those skeletal meshes, that can be very expensive. Another area is animation evaluation. And that is because when we set up our metahumans, there are certain features that you need to use in the animgraph, and some of those features can be expensive. Oftentimes, with skeletal meshes, you're thinking about bone count. High-end metahumans have hundreds and hundreds of bones with lots of levels of the influences per vertex, right? And then prior to 5.6, in the animgraph, the big thing that I mentioned before, and I'm going to reiterate this because it's been a big problem, is the post drivers inside of the animgraph. So a couple tips. In general, one of the things that you want to do is you want to figure out where you're going to be profiling. You can profile on your editor build, but if you're building towards a target platform, definitely look to profile on your target platform using the project launcher with a few settings. On top of that, you want to start in development mode. Development mode is the slowest mode for your game. It has a lot of the code evaluation and breakpoints and things. And so start there for the big picture. It'll highlight areas that you might want to check in on, and then build your game and cook it for test and profile there using Unreal Insights. And you can get pinpoint better accuracy on where specific calls are more expensive. The other thing that we recommend too is on top of your game, which is always good to profile in context, make a test level where you isolate your character to really go down deep on what might be causing performance issues for that specific character. And like I was saying, test on your platform. Launch the project into your PS5, launch the project into mobile if you're doing metahumans for mobile, for example, and test it out and make sure that you can see what's going on there. In terms of animation profiling, there's a few tools to figure out where things may be going awry. There's a few console commands. I'm going to talk about control rig because we do use control rig inside of Metahuman. And then lastly, Unreal Insights. So in terms of console commands, this is a very dense slide, and luckily you can read it on this screen a little bit easier. But whenever you use stat commands, the first one that you want to try is stat anim. Stat anim is a command that you can put in your console. It'll pop up a little UI widget in your screen that shows relative cost per frame, and you can see that over time. So as you change things in the editor, this will change and be evaluated on a per frame basis. And it might show you areas within your anim graph that might be expensive, something that might be high. But as you change and animate your character, you might see things shift as well. So it can highlight areas that you can figure things out. Then there's the standard stat unit and stat unit graph. These just show overall scene expense, and they can also help pinpoint if maybe your metahuman isn't the most expensive thing. There's something else that's causing issues. And lastly, it's not as useful, but it can be, is stat GPU, because say, for example, you did accidentally export a very high-end metahuman, it'll show up in the stat GPU for all your rendering issues that you, or texture material, things that are causing issues on your GPU. All of this is to help you guide you towards where might the answer be. So I want to talk about control rig. We do use control rig inside of Metahuman, and on top of that, we are recommending using control rig at Epic more and more for lots of other features too. And one of the coolest features inside of control rig is the ability to understand where aspects of your control rig are hot. So I'm going to play a video here that shows this in action. So what you do is you go up to your class settings, you go down to enable profiling, you turn it on, and then there's a couple options to enable some other stat commands to see how many cycles something is costing, and it'll show you in a heat graph method areas that are expensive in your graph, and that might be an optimization opportunity where you can go look and be like, why is that node expensive? And in the update to from 5.5 to 5.6, we actually found a node within the Metahuman graph that once we tuned it up, we saved 25% of the cost on the new Metahuman control rig nodes. So automatically very useful. It's worth investing time in and learning. And then lastly is Unreal Insights. Every TA, I highly recommend. Most engineers know about Unreal Insights, but if you're a TA or you're an artist that's looking to get into performance profiling, learn Unreal Insights. We have a lot of talks about this at Epic, and I think there's even a couple here, but it is your forefront tool to figuring out where cost is happening per frame. It can be really daunting, but I promise you, once you learn it, you'll be so happy. You can access it directly inside of the pie. It's in the bottom right. You can turn it on. And there's two ways to go about using Unreal Insights. The first one is you can just run and do a trace, and it will report back information about your frame where slowness might be across also your threads. But you may miss some understanding about what is happening with specific frames because you need to turn on a console command or a argument flag for sending over to your profile stat named events, and this is going to give you much more information. It is going to slow down your game, and it's not representative of the cost of your game because the stat named events is more computationally intensive during the trace, but it can highlight areas where there is slowness, and just know that once you turn that off, you're going to get, better performance. Okay, so we know how we're going to profile. We've created our metahuman. We've done one that is, maybe it's a medium or high. Where do we want to start optimizing our metahuman? These are learnings that we've taken over the past year or so, TechNerdRel as well. So the first step is to audition your LODs. Drop your metahuman in, shift down the LODs, take a look at it in context, and see which LOD actually looks good and what is useful for your game. You may not need LOD 0 or 1 for your game. You could actually get away with LOD 3, for example. And if that's the case, start with LOD 3. For most games, that are high-end games that are working on like PS5, we recommend starting at LOD 2. And then going from there, you can optimize further. The next thing is on your metahuman component, the component that's inside of your blueprint actor, there are a few options that you can just immediately toggle to see how things look and if you even need them. One of them is your correctives. These are impactful for perf. We mentioned this before with opposed drivers. But if you can turn them off and you don't see an issue with your metahuman, just leave it off. You can just turn it off easily that way. Another area is you can change your animation LOD threshold and turn off certain features of your anim blueprint by raising that threshold up. It's So if you don't need certain things at longer LODs for your NMVP, you can do it here. Okay, pose driver optimizations. This is a deep topic because, again, this is the highest cost prior to 5.6. So pose drivers, what they do is they prevent artifacts and they handle deformation and volume preservation for certain areas of the body, mostly in the shoulders and inside of the neck. And so if you don't need them, you can turn those off, but if you do need them, try seeing which ones you might need and which ones you don't. There are two sets, basically. And then further, you're like, okay, I'm on 5.5 and I need to use them. There are other opportunities available to you instead of just upgrading the engine. They are extensive though, so if you're an experienced rigger, this is a place to start. You can start looking into spherical pose rigger or the RBF functions inside of control rig and move the pose driver evaluation out of the NMVP and into control rig, which is a much faster and cost-efficient method. Lastly, if you can upgrade to 5.6, it's packed in 5.6 and you're gonna get the most things. Okay, the other big cost for metahuman animation is facial animation. And if possible, if you can turn it off, if you say you're building crowd characters and you don't need that facial animation, don't animate the face. The other option is if you can save on your bone count, you can remove some of the bones from the face as well. And if possible, bake that pose out that you might need to create a good looking face for that crowd, and then remove those bones entirely. If you want to go even more aggressive on facial performance changes, you can start to look at the material and start removing some of the animated maps. The other option that you have is that you can drive the face and the head via the leader pose component, which basically does not evaluate any of the NMVP at all, and especially in 5.5, where it has its own facial animation VP, you can do this instead. You'll lose all the facial animation and the fidelity there, but it is possible to do this between LODs too. So say you need to do a close-up with LOD 2, but then this character needs to move further away, you can actually drive that other LOD with some blueprint to using the leader pose component. The other thing that you can do is you can disable the post-process NMVP from the face mesh component. This will help on some savings. And lastly, a very risky, but it's if you're capable of doing this, you can tune the mesh to bone ratio on some of your LODs. So you can remove some bones while keeping the mesh fidelity high, and just overall reduce the bone count using LOD settings inside of your skeletal mesh. Recompute tangents. This is a big visual improvement that we need to have for when we animate the face, but if you're not animating the face, just turn it off. It'll save on GPU cost. That said, it can make your characters kind of ugly. So you can see this on the top left. You've got the character with that big mouth pose, and the creases in the mouth, the cheeks don't happen. That's what's going to happen if you turn these off. But if you're not animating the face, you just go to your slot in the section of your skeletal mesh and turn off recompute tangents. Another thing that Metahuman brought to Unreal was unlimited bone influences. And this was necessary because we have hundreds of bones inside the face and a limited set of vertices, and a lot of bones need to drive different sections of the face. And so there's tiny little weighting all over the place. And this was necessary to be able to support high fidelity characters. The issue is that this also causes problems where the more vertices that you have, it will chunk the mesh and cause a rendering curve hit. And you can reduce that overall count. And we recommend this also for just doing basic skeletal meshes in game. Think about how many influences are being controlled per vert. We, on UAFN, needed to do this. We couldn't afford this. So we actually built a deformer graph that handles this under the hood. And that might be something that you want to look at in the future. But if you do turn down the amount from unlimited to say 12, for example, you might see some issues occur with the skinning on the face. So something to be on the lookout for. May not want to use it for your hero characters if they're getting up close to the camera. Say you want to go even further, and the materials for Metahuman, you're running into GPU issues and you want to optimize the materials yourself. You can do that. We automatically do this for optimized metahumans. We modify the high-end materials, make them cheaper, less complex. They do still have a lot of complexity inside of them. And this is default in the Metahuman 5.6. We've done a lot of work on optimizing the materials. But if you want to make your own materials, you can. It could save on texture sizing and GPU curve if you set them up the way that you want. The main thing is that you want to think about looking at the original material, seeing what features that you might need, and then porting over the ones that are important, and then making sure that you turn on one feature, which is material parameter caching. So this is super easy to miss. And we have it on by default in the material for Metahuman. And it's critical for performance, especially if you have a lot of animated parameters like we do for all of the blood maps and all the other features for wrinkles and things like that. If you don't check this on, and it can actually cause a hitch on the game thread in prep and sending information over to the GPU. So if you're creating your own materials, ensure that you go and check the enable material parameter caching on, and it's going to save on some of that cost. Another area that's really important for optimization is reducing your grooms and thinking about how you develop your grooms. Hugo's going to go over developing grooms in Houdini for Metahuman, and as you're preparing for building grooms for your game, you're going to want to think about reducing your CV count, reducing your guide count. If you don't need to see some points, cull those out. And a small trick that you can do is, say you're reducing the overall density of your groom, you can thicken the strands to still get that feeling of a lot of hair in the character. And just remember that strands are very susceptible to lighting and your pixel coverage. So if you're creating up close cameras and you start to get shimmer, you might be bouncing a little bit the wrong direction. But overall, we want to keep it below that 100K, 2K. And on top of that, when you import your groom now in 5.6 from Houdini to Unreal, we actually throw up some warnings for some maximums that we recommend so that you don't go too far on your groom. But if you follow this, you'll be in a good spot. And lastly, if you saw my talk yesterday on Mutable, another great step that you can take to take things even further by reducing your mesh counts and combining meshes is using Mutable. Mutable is a plugin that comes with Unreal, and its goal is to merge meshes and customize characters. And it's got a couple key features associated with it, on top of being able to merge those meshes to reduce your component count, to remove parts of your mesh. So, for example, I create a parametric body with clothing components. Maybe I want to combine those, and then I can hide all of the polygons that are underneath the shirt, and you don't need those. On top of that, Mutable now supports passing through the DNA file as metadata. So all the animation tooling that comes along with Metahuman can be passed through. You can combine your meshes, and things will still work properly. And it supports 12 influences per vertex, the thing that I talked about in reducing cost earlier. So this is a great tool for you to be able to dive into at the very end if you want to get that, squeeze the juice out of that last bit of the Metahuman there. So, to wrap up, use your profiling tools. Use your optimized metahumans, please. And then also look at the areas that you may want to optimize. Audition your LODs, take a look at your anim graphs, take a look at your materials and textures, see where you might be able to combine things, maybe using texture graph, and take a look at your grooms and see how they're being developed and see if there's savings there. And last, if you need to use Moogle, you can to combine those component parts to create more optimized crowds and characters in your game. So with that, thank you. And I want to say a special thanks to Jerry Bonson and the Metahuman team for letting me present. So we've got 15 minutes. I'm going to spend 5 minutes to answer any quick questions, but from there, I'm going to head out. I'll be in the animation lounge if you want to ask any more questions. And if I can't answer anything for you, for whatever reason that might be, I'll get that in front of the Metahuman team and we can get you guys connected. They're very eager to talk with folks. So, anybody have any questions? There's one over here.
Hi. You mentioned that the license has changed. Does that mean that Metahuman now has full source access within the engine? Because before we were like pulling from our external partners, but now do we have engine source access for the plugin?
I don't know the answer to that. It is inside of the engine now. I'm unsure. I haven't actually looked at the availability of that code. So it is in the engine.